My name is Anthony, and in this study, we look at developers repaying technical debt through refactoring operations. We do this by examining occurrences of self-admitted technical debt removal in the code of 76 open-source Java systems. Technical debt is a reference to any non-optimal code that is shipped to production with the promise of enhancing it in the next cycle. Furthermore, as part of planning their correction, developers document these deficiencies as comments in the code, and this is known as self-admitted technical debt, or SATD. In this study, we explore the repayment of technical debt through refactoring operations by using self-admitted technical debt as a proxy for technical debt. Hence, the removal of such comments in the code indicate that the developer removed or repaid the technical debt in the code. Our work helps developers to understand the potential areas of quality concern in the code and provide tool vendors with the opportunity to empower the community with improved code maintenance tools. We have two research questions. The first examines the volume of occurrences of technical debt removal and the types of refactorings that developers frequently apply. And the second examines the repayment categories for which developers refactor their code. A tangible outcome from this study is a publicly available dataset which can be utilized in future studies in this area. To answer our research questions, we utilized the Smart Shark dataset. From this dataset, we extracted the data pertinent to our study using custom Python scripts. Next, to answer our research questions, we followed a mixed methods approach where we collected and analyzed both quantitative and qualitative data. Our findings show a frequent co-occurrence between debt repayment and code refactoring, with developers applying a variety of refactoring operations. We observe that developers frequently apply the extract attribute operation multiple times in a file. Furthermore, there is a significant difference in the volume of refactorings developers apply when removing technical debt compared to general maintenance activities. Analysis of self-admitted technical debt comments show that developers refactor to repay technical debt for multiple reasons. These include improving error handling, such as replacing try-catch blocks, optimizing the code, such as performing cleanup activities and design improvement, and finally, refactoring to incorporate feature changes is another reason for debt repayment. Exploratory study, we show the potential for future research in this area. Our RQ1 findings confirm prior work showing that the removal of technical debt is frequently associated with refactoring actions. Our RQ2 findings provide a good starting point for the establishment of a more formal taxonomy on repayment categories. Our study also shows the potential for code quality tools that can exploit the relationships between debt repayment and refactoring operations using static analysis techniques. For instance, tools can either warn developers or automatically update error handling when developers use auto-generated try-catch blocks. Furthermore, refactoring tools can improve the accuracy by considering the occurrence of SATD in the code. Thank you.